Lesson 3.6 is called multi-step equations. This is in your notes packet on pages 12 and 13. So for multi-step equations, we're going to go back to this "don't call me after midnight" little phone that we have here. And when we have multi-step equations, what we're going to see today is either a distribute step or a combine like terms step. We're going to eventually put these all together here, but today we're just going to keep it one or the other. So you'll take care of that. We're still skipping over this move the variable that's coming up. So distribute first, combine like terms if you have it, add, subtract, and then multiply or divide. Your goal is still the same, that you're trying to isolate the variable. So in example number 1, my goal is to isolate the variable. Ultimately, I need to distribute or combine like terms so that it looks like a two-step equation, so that then I can add or subtract and multiply or divide. I notice if I split these up, I have 3m split plus 9 split plus 4m. Looking for my like terms, I have the 3m plus the 4m, which will give me a 7m. And then I have plus 9 equals 2. So this side is going to stay the same. I only simplified this one side. You're going to follow at this point, it looks like a two-step equation, so just follow your normal steps. Add and subtract first. 7m is equal to negative 7. Divide by 7 on both sides so that you get 1m, which we write as just m, equals negative 1. In example number 2, 3a split plus 12 split minus 6a. So 3a and a minus 6a come together to give me negative 3a plus 12 equals a negative 9. I'm going to go ahead and subtract 12 on both sides. And I'm going to have negative 3a equals negative 21. Divide by negative 3 on both sides. That'll give me a. And negative 21 divided by negative 3 is positive 7. I'm going to have you go ahead and take a look at question number 3 here. Split it up. You have 7a plus 12 minus 4a. Combine your like terms, get it to look like a two-step equation, add, subtract, multiply, divide, and try and get a by itself. So combining the like terms, 7a and minus 4a is going to give you a positive 3a, plus a 12 equals a negative 9. So you're going to go ahead and subtract 12 on both sides, and you're going to get 3a is equal to a negative 21. And if you divide through by 3 on both sides, that'll leave you with a, and negative 21 divided by 3 is negative 7. Same style also, I'm going to have you combine your like terms and go ahead and solve number 4. So combining like terms, I have 3s and negative 6s, which will give me negative 3s. And a net minus 5 is equal to a 4, not a negative 4, excuse me. And I'm going to add 5 to both sides. Those cancel, so I have negative 3s equals to 9. Divide through by negative 3. And I'm going to get s equals negative 3. The next two examples are going to show you a distributive property problem, and you can really approach these one of two ways. Sometimes when we get into more complicated equations, we're going to actually have to distribute every time, but another strategy is available here. So just straight up distributing, you would go ahead and use the distributive property, and you get 3x plus 6 equals 18. So then following your two-step, you would add, subtract. So you're going to go ahead and subtract 6. 3x is equal to 12, divide through by 3, and you get that x equals 14. One of the other methods that you can see is if you only have distributive property here, this is multiplication, and technically you can approach the parentheses last, so we could actually divide by 3, which would cancel that out, and we have to do it on both sides. This leaves you with x plus 2 is equal to 6. And I'm looking back here, I totally wrote this wrong. I wrote down a 14, and this should really say a 4, because 12 divided by 3 is 4. Over here, coming back over to the right side, then I subtract 2 to get x by itself, and I get x equals 4 then. So if it's just distributive property, this is another option for you, and you are welcome to do it that way if you would like to. So I'm going to have you turn it on over to page 13. I'm going to have you take a look at example number 6. Using either of those two strategies, go ahead and solve. So I just prefer to distribute because ultimately that's going to be our strategy kind of in the long run. So I'm going to show that to you this way first, and I'll also show you the other way. So distributing, add the 20 to both sides. You get 5a is equal to 50. Divide by 5 on both sides, and you get a is equal to 10. Now, had you done the other strategy, equals 30, you would have divided by 5, which would cancel that out. And then you get a minus 4 is equal to a 6. Add 4 to both sides, and you would still end up getting a equals 10 using either of those strategies. Example number 7, this one's a combined like term, so I have 5x plus 3x, that'll get me 8x, a plus 3 and a plus 4, which will get me a plus 7, and this is equal to 23. So I'm going to subtract 7 on both sides, and I get 8x is equal to 16. Divide through by 8, and I'm going to get x equals 2. So that's how you basically solve just straight up solving equations problems like this. The next couple examples are all going to be word problems. And example number 8, we're going to talk about consecutive integers. Consecutive integers just mean counting. So as you're counting, consecutive would be one after another. So for example, if I said 1, 2, 3, you would know to continue 4, 5, 6, 7, 8. So we're going to be looking for 3 consecutive integers that's going to give us a total of 375. So I'm going to put 3 blank spaces here and equals to 375. So what I want you to do is we're going to write down the side here, number 1, number 2, and number 3. And we're going to call our first number x. And I want you to real quick look at a pattern. So if I had 6, 7, 8, these are consecutive integers. If I called this one x, what do I do to get from 6 to 7? So when I'm counting, I'm actually adding 1. So if this were called x, to get to 7, I would do x plus 1. And if I were trying to get to the next one, I would have to do x plus 1, which is this one, plus 1 more to get me here. So this would actually be called x plus 2. So when we do consecutive integers, our first number is going to be called x. Our next number is going to be x plus 1 because we're going up 1. And then our third number would be x plus 2. If we wanted a fourth, we would call it x plus 3, and so on. So I'm going to go ahead and actually plug these into my equation. So x plus 1, and x plus 2. And I need to combine like terms. So I have x, x, x. So that's 3x. And plus 1 and plus 2, which would be a plus 3. And this is going to be equal to 375. So I could subtract 3 on both sides, cancel. So I get 3x equals 372. And then I'm going to go ahead and divide by 3. And x is going to equal 124. So if my 3 integers start at 124, you're just doing counting integers. So 124 plus 1, my next number is going to be 125. And what is my final number going to be then? Counting, you're going to add 1 more on or add 2 to where you started, so that's going to be 126. If we add those 3 together, we get 375. Example number 9, we have consecutive again, so we're going to be counting, only this time we're counting by evens. So we have 2 numbers that we're going to add together, and we're going to get a sum of 58. So we have number 1 and number 2. We're going to start by calling number 1, 1. Counting numbers, we added 1 every time. But if I asked you to count by evens, 6, 8, 10, every time you go, you're actually adding 2. So instead of x plus 1, when I count or go by evens or even odds, I'm adding 2. So it would be x plus 2. So I'm going to have x as my first number and x plus 2 as my second. Combine my like terms, and I get 2x plus 2 equals 58. Subtract 2, and I'm going to get 2x is equal to 56. Divide through by 2, and I get x is equal to 28. So that's my first number. X is 28, and 28 plus 2 is going to be 30. Double check, are these two consecutive in order even numbers? They are. 28 and then 30 would be my 2 numbers here. In example number 10, you have a part-time job. You work 3 hours on Friday, 6 hours on Saturday, And then you also, so plus, receive an allowance of $20 per week. In 1 week, you earn $92. So this is your equals number. How much do you get paid an hour? Write and solve an equation. So 3 times your pay plus 6 times your pay plus your $20 allowance gives you your total of $92. I'm going to have you go ahead, combine your like terms and solve this. Make sure that you put a label with your answer because the question says, how much do you get paid an hour? So combining your like terms, you get 9x plus 20 is equal to 92. You're going to subtract 20 on both sides, and you get 9x is equal to 72. Divide through by 9, and you get x equals 8. Putting a label with it, $8 per hour is what your pay is. In example number 11, Julie sold 43 packages of taffy for this year's PTA fundraiser. This is equals 1 less than 4 times the number of packages sold last year. So this is 4x because we don't know how many packages last year because that's the question. And 1 less means to do minus 1. So 43 is equal to 4x minus 1. I'm going to have you go ahead and solve this one. Make sure you include a label on your answer. So add 1 to both sides. 44 is equal to 4x. Divide through by 4. And we get 11 equals x. So for Julie, we could say Julie sold 11 packages last year. And if you just said 11 packages last year, that would be perfectly acceptable too. And that wraps up lesson 3.6 then, solving with distributing or combining like terms.